Hello everyone, welcome back to this channel. In this video, we're going to look into Chapter 2 of IGCSE Math, Fractions, Percentages, and Standard Form. And this is the chapter outline. And the first subchapter of the chapter is fractions. Now let's quickly first define what a fraction is. A fraction represents a part of the whole. It has two parts, the numerator and the denominator. So the numerator is the number of parts you have. Denominator represents the total number of equal parts. And they can use to represent different real-life scenarios. And for example, I have this watermelon here. So in total, I have 5 parts, but only 4 parts remain. Same goes to this pizza example. How many pieces that are remaining? That's 6 pieces out of 10. And another term in fraction that you need to know is mixed number. It has a whole number and a fraction combined together. Say you have 2 pizza and some part of the pizza, and this is when you can use the mixed numbers. So 2 fractions, they are equivalent if they represent the same amount. You can find equivalent fractions by either multiplying or dividing the numerator and the denominator. So for example, 2 over 3 here, if I want to find an equivalent fractions, I can multiply, let's say, the numerator and denominator by 2, and that will give me 4 over 6. So this fractions here, in quantity term, it is equivalent to 2 over 3. So you can also multiply, let's say, by 3, that will give you 6 over 9. And that's also an equivalent fractions of 2 over 3. So again, you can multiply by 2 or multiply by 2 again. You'll get another equivalent fractions. So that's how easy it is to form it. Alright, now let's solve some work example. Find 3 equivalent fractions for 5 over 7. Well, I can multiply by 2 or multiply by 5, multiply by 3, and that will give me 10 over 14, 25 over 35, and 15 over 21. But you can technically multiply any numbers you like, and that will give you the equivalent fractions. Well, it is also very important to simplify fractions so that you get the simplest form. So a fraction is in its simplest form when the numerator and denominator have no other common factors other than 1. So to simplify, you have to find out what's the highest common factors between the numerator and the denominator, and then divide both the numerator and denominator by the HCF. So in this example here, 2 over 5, the HCF of 2 and 5 is 1. So if you divide 2 and 5 by 1, you get just 2 and 5. Nothing changes because this is already the most simplified fraction. Whereas on the other hand, if you were to simplify 24 over 36, we know that the HCF of both numbers is 12. So if you were to divide both numbers by 12, you get 2 over 3. And that's when you get the simplest form of this fraction here. So if you were to look at it again, the HCF is 1. Therefore, we say they are not simplifiable. They are already in their simplest form. Whereas this is simplifiable because their HCF is more than 1. Now, another work example. Let's try to simplify this. So first, find out what's the HCF of 15 and 25. And if you were to apply the methods we used in the last chapter, you'll find that their HCF is 5. And that's when you can divide both numbers by 5. 15 divided by 5, 25 divided by 5. That's when you'll get 3 over 5. And that is the simplest form of this fraction. We're done. Now, let's solve a question here. Is 18 over 36 equal to 3 over 6? And to solve this question, you do have to convert both fractions into their simplest form. For example, to convert this into their simplest form, find out what's their HCF. So happen that their HCF is 18. So you divide both numbers by 18, you'll get 1/2, 1 over 2. And same goes to this. Their HCF is equal to 3. That's when you can divide both numbers by 3 and you'll get 1 over 2. And they are equivalent. That's why the statement is true. Now let's look into the second subchapter, fraction operations. We're going to learn addition, subtraction, multiplication, and division, etc. So first, addition and subtraction. So there are 2 question types. The first one is when the denominators are the same. So in this case, you can keep the denominator, just add the numerator, and then you would have gotten the answers. Well, the second type of question involves fractions that have different denominators. The first thing that you have to do is to make the denominator same again. To do that, you have to know what is the LCM of both numbers. And in this case, if you use the method that we learned in the last video, you'll find that their LCM is 45. So to convert these fractions to have a denominator of 45, I can just multiply each other's denominator. For example, 5 I can multiply by 9, and because the denominator is multiplied, the numerator has to also multiply, and do the same to 9 multiplied by 5, 2 times 5. So if you were to do that, you have 27 over 45 plus 10 over 45, which will give you 37 over 45. So as I mentioned, just make the denominator the same, and then you can add it up and get your final answer, 37 over 45. Alright, now let's try to practice fractions with calculator. So imagine receiving a question like that. So how do we type these fractions into our calculator? So I have my calculator on my hand, you can pull out yours, and on your calculator, you should be able to see this fraction symbol, but then you couldn't type out the whole number. So what you can do is to press the shift button and then key in the fraction button again. That's when you have the mixed number operator placeholder, and then I will just key in my value for 1 over 8, and then once again minus, press the shift button and fraction 3, and then 1 over 16, and then press execute. That's when you have 17 over 16. And alright, that's how you use a calculator to do addition and subtraction for fractions. Now let's move on to multiplying fraction. You can do this without using the calculator. The rule of it is that we'll multiply the top and top, which is the nominators, and multiply the bottom and the bottom, the denominators. For example, 1 over 3 multiplied by 5 over 8, you will get 5, 1 times 5, 5, and 3 times 8, 24. And that's how you solve it, easy peasy. And there will also be time when you get a mixed number in operation like that. The first step is always to change this into an improper fraction. So to do that, you know that one whole number, it can be converted into 2 over 2. So when you do 2 over 2 plus 1 over 2, that's when you have 3 over 2. So this can be converted into 3 over 2 multiplied by 3 over 7. And if you were to multiply both the numerator and the denominator, you get 9 over 14. So that's the answer here, 9 over 14. Alright, that's multiplying fractions. Let's move on to dividing fractions. So to divide fractions, you do need to know how to multiply because in this rule, it says that if you were to divide A over B by C over D, you can change the operator by reversing the numerator and denominator. You can change the numerator and the denominator of the second fractions. So for example here, 2 over 7 divided by 1 over 2. You can change the operator by saying 2 over 7 multiplied by 2 over 1, which will be equal to 4 over 7. So in this case, that's how you do it. So there will also be time where you will be asked to divide mixed numbers. So the first step that I will always take is to convert these fractions into improper fractions. For example, for the first one, I will convert it into 9 over 4 divide by 10 over 3. And after that, everything will be as usual. You will flip the division operator into multiplication and then flip the numerator and denominator of the second fraction, which will give you 3 over 10. So you just multiply them together and you would have gotten the final answers. So convert mixed numbers into improper fractions and then multiply them together and then you'll get the answer. So the next part of the lecture talks about how to deal with fractions that has decimal in it. So to do that, you have to convert decimal into fractions and then simplify. So in this case, 0.6 over 0.8, I will first convert it into a proper fraction. I'll just multiply two parts by 10, will give me 6 over 8, and that's how you convert fractions with decimals into its simplest form. So another example here, 0.1 divided by 7, I would just multiply this 2 by 10, will give me 1 over 70, and that will be my simplest fraction, 1 over 70. So just one more example, if you have 0.6 divided by 0.12, you can once again convert these decimals into fractions. So in this case, I'm just going to multiply by 100, and then 0.6 multiplied by 100 is 60, 0.12 multiplied by 100 is 12. So once you do that, 60 divided by 12, that's 5. So you will see that the answer here is 5. So there are multiple methods to do it. You can convert it to fraction too, and then just use the same method and you would have gotten the same answers. So 1/10 of the students in the school do not have a phone. If 25 of them do not have a phone, how many students are there in the whole school? So the question said 1/10 of the people have no phone, and 1/10 is equal to 25. So the whole school is going to be 9. So we know that the whole school is going to be 10 out of 10. So to do that, you can just multiply 25 by 10. You would have gotten the total number of students in the school, which will be 250. All right, now let's solve some questions on fractions operation. So add these fractions up. Again, the simplest way to do it is always to convert it into improper fractions. So in this case, I have already converted it into improper fractions. And once you've done that, you still cannot just add them up because their denominators are not the same. That's when you will make the denominator the same by converting it into an equivalent fraction. And once you've done that, just add everything up and you would have gotten the final answers. So another question which involves you to know a little bit of the order of operations. So what you can always do is to convert your fractions into improper fractions. And then because we're solving those that are in the bracket first, we'll make the denominator the same and then do our subtraction. And once you have gotten the result, we'll divide by 7/3. So we can change the operator by swapping the numerator and the denominator of the fraction. So once you've done that, just multiply them together and you would have gotten the final answers. And that's about it for fractions operation. So in the next part of the chapter, we're going to look into percentages. So these are the learning objectives. So first of all, what is percentage? The term percent means per 100. So if you have 25%, it means 25%, 25 per 100, whereas 75 means 75 per 100. So this is some illustration to help you understand. So a jar contains 100 marbles, 68 of them are blue. Write the percentage that are blue. So in this case, they are exactly 100 marbles, so we know that it's 68%. So how do we convert percentage to decimal? Something that you have to know. The method is to divide the percentage by 100. So you have 46%. To convert this to decimal, convert 46, divide 46 by 100, you'll get 0.46. Whereas if you want to do it another way around, convert decimals into percentage, you will multiply the decimal by 100. So it will be 23%. So the next thing that you have to know is to convert percentage into fractions in its simplest form. So to do that, you do have to do two things. First, you have to divide the percentage by 100, 46 divided by 100, and then simplify, and that's how you convert percentage into fraction. Whereas if you want to do it another way around, you just have to multiply the fraction by 100, and then you would have gotten the percentage of this fraction, which will be 66.7%. Well, let's do some practice. Convert 0.74 to percentage. The hint is to multiply by 100. It will be 74%. So the next practice, convert 0.25% into fraction. That's a bit little. The hint is to divide the percentage by 100. So I'm going to divide 0.25 by 100 and then make it into a proper fraction. And once I simplify it, I will get the fractions of 0.25%. All right, how do we express one number as a percentage of another? For example, how do I find out what's the percentage of 14 out of 35? So to do that, you do have to form a fraction by using the part divided by the whole and multiply by 100. So in this case, 14 as a percentage of 35 will be 14 over 35 multiplied by 100, and that's when you get the percentage of that number. So practice, express 48 as a percentage of 320, 48 divided by 320 multiplied by 100, you get 15%. So the next thing that you would be asked to do is to find the percentage of a number. For example, what is 20% of 60? So to do that, you have to first convert the percentage into decimal. So which will be 0.2 because you can just divide by 100 and then multiply 0.2 by 60 and then you would have gotten 20% of 60. So this is how it's done. All right, let's do some practice. Find 0.01% of 60. First, you have to convert this into decimal by dividing it by 100, which will give you 0.0001. And then multiply this by 60 and you have got 0.006. So that's how you do it. All right, the next thing in percentage is to find out the percentage increase or decrease for two values. For example, 56 to 61.6. How much percentage change are there? So to do this, you can apply this formula. So you will use the new value, 61.6 minus 56, divide by the original, 56. Multiply by 100%. So if you were to calculate everything, you would get 5.6 divided by 56 times 100%, and you will see that the percentage increase is 10%, once you compute that out. Alright, practice time. 5% change from 300 to 267. There is a decrease here. So the final value is 267 minus 300 divided by the original 300 multiplied by 100%. And if you were to compute this, you will get negative 33 over 300 times 100%, and that will give you minus 11%. So that's the amount decreased here. Well, there are also times when you have to calculate what's the final value after a percentage decrease. And there are two methods to do this. The first method is to use something called a multiplier. So if the percentage increase is positive, this is how you create your multiplier. You will do 1 plus p over 100, p is your percentage. So if your increment in percentage is 10%, your multiplier will be 1 plus 10 over 100, which will be 0.1. So 1 plus 0.1, that's your multiplier, 1.1. So for decrement in percentages, it's the same, except that now the operator has changed. So if there is a decrease by 10%, then instead of adding it, you minus the percentage. So which will be 1 minus 0.1 will be 0.9. That's your multiplier. Now let's try to use this in practice. Increase 72 by 112%. So first you can construct your multiplier. Multiplier is 1 plus the amount of increase in percentage over 100. That's 1 plus 1.12. So your multiplier is 2.12. You just have to multiply 72 by 2.12. So if you were to plug everything into the calculator, you would have gotten the new value after the percentage increase. So the second way to calculate a new value from a given percentage change is to use a bar model. For example, decrease 200 by 20%. In this case, you can draw this bar here, 100%. The original price is 200. And then draw another box here to show the decrement, in this case, decrease. What is the price at 80%? So to solve that, we know that 100% is equal to 200. But then since now the value has been decreased by 20%, okay? So what's remain is 80%. So what we can do here is to first figure out what's the value of 1%. So if 100% is 200, then 1% is equivalent to 2. So to figure out what's the value of 80% here, you just use 80 multiplied by 2, and it will give you the final value after the decrease has happened. So in this case, x is 160. That's how we get it. Find out what's the value of 1%. All right, now let's solve up another practice. There will also be time when you can use bar model to calculate the amount of increment. For example, in this question, increase 80 by 15%. So from the bar model, we know that 100%, which is the original, is 80. And then we can increment this to 15%. That will be 115%. And we have to find out what's the final values. Again, we can use the same method. If 100% is equal to 80, then 1% will be equal to 0.8. So what is the final value if it's 115%? So we can do 115 multiplied by 8. So if you were to plug everything into the calculator, you'll get 92. And that will be the final value after the increment. So having this bar model helps you to visualize the increment and decrement better. All right, now let's move on to reverse percentage. What if you were given the final price and the amount of discount and you were asked to find out the original price, which is what happened here. And what they say is that after a 15% discount, which means you only pay 85% of the original price, the price is 680, find the original price. So you only pay 85%. So if you convert it to fraction, that's 85 over 100 and multiply by an original price, something that you should be paying. And the price after discount is 680. So to find out the original price, we need a little bit of linear equation, which we'll touch on in the chapters to come. But in this case, we can move 80 over 75 because here initially we are multiplying it. But when we move on to the other side of the equation, we'll be dividing it instead. So if you were to plug everything into the calculator, you can figure out what's the value of original, and that will give you the original price. So that's reverse percentage. Well, if this method doesn't feel comfortable to you, you can also use the bar model method. The same question, again, we have a 15% discount. So after the discount, the final price is 680. So we can use the same method technically. 85% is equal to 680. Let's find out what's 1%. To solve what is 1%, you can do 680 divided by 85. If you were to key in this into the calculator, you'll get 8. Therefore, to calculate 100%, which is the original price before the discount, you can do 8 times 100, which will give you 800, which is something that we calculated as before. So these are the two different methods you can use to calculate reverse percentage. Well, let's practice for another question. A shirt is sold for $42 after 30% discount. What was the price before the discount? Once again, 70% is 42 pounds. What is 1%? So to do that, you can do 42 divided by 70, and 100% will be 0.6 times 100, which will give you 60. So 60 is the original price. Here you go. Well, let's solve some question. Convert 84% to a fraction in simplest form. I can always move it, divide by 100, and then do some simplification, and I would have gotten 84% in simplest form. Another question, 15% of 20. I can convert this into multipliers, 0.15, and then multiply it by 200 to get the value. So express 36 as a percentage of 90. Just let 36 divide by 90, multiply by 100%, and you will have gotten 40%. Decrease 480 by 37.5% using a multiplier. So again, multiplier original value is 1, but because we have a decrease here, so we have to convert 37.5% into decimal, which is 0.375. 0.375, that will be 0.625. That's our multiplier. Multiply this by 480, and you would have gotten the final value after the decrement. So hard question, after a 25% discount, an item cost £300. What was the original price? So in this case, I'm going to use the bar model method. Initially, it was 100%, but we are only paying 75% of the price because we have a discount. That's 300. So you can calculate what's the value of 1% and then use that answer, multiply by 100, you would have gotten the original price. So another hard question here, a town population rises from this to this. Find the percentage increase, give your answer in 3 significant figures. So the final value minus by the initial value, divide by the initial value, and then multiply by 100%. So if you were to key in this into the calculator, you would have gotten this value, multiplied by 100%, and you'll get 9.15%. Alright, and that's about it for percentages. Now let's move on to standard form, and these are the lesson objective. So standard forms is useful for a very large number because, for example, describing the population of the Earth, instead of writing so many zeros, you can simplify it using standard form. They are also used for very small numbers like the size of a cell, and that's how you do it. I'm going to teach you how to convert this huge or very little number into standard form in a bit. So the structure of a standard form is this. You have a base number, A, and then this value must be in between 1 and less than 10. Okay, just a single digit, but not 0. And this n here, it is an integer. It cannot be a decimal or fraction, and then it can be either positive, negative, or even 0. So as I mentioned, A must be in between 1 to 10, but not including 10. So that's why you cannot write your standard form like that, because 0.23 is not more than 1. So you have to write it in this way. Without further ado, let's learn how to convert large number into standard form. Say you have 45,000. How do we convert this into standard form? So to do that, I have a little trick here. I'll just convert 45,000 into 45,000.0. So at least I can see the decimal point. Our goal is to move this decimal point into this part so that we can have 4.5, which is in between 1 to 10. Alright, so to do that, you have to understand the implication of moving your decimal point. If your decimal point moves to the left, the index of your standard form is positive. Okay, what do I mean by that? So our goal is to move from here to here. Okay, so to do that, I'm going to move 1 step, 2 step, 3 step, 4 step. My decimal has moved 4 steps to the left, 4 steps, which means that my final value will be 4.5 times 10 to the power of 4. Positive because we move to the left. So in this case, I have a better illustration. 1, 2, 3, 4, 4 steps. The decimal moved 4 steps to the left before reaching a number between 1 to 10. That's why my final digit is 4. To help you to understand better, let's do an example for small numbers. Say I have 0.0063. Our target here is to move this decimal point into here so that we have 6.3, which is in between 1 and 10. So to do that, let's just undo everything. Let's move 1, 2, 3. So we move 3 steps to the right. Because we are moving to the right, our index is negative. It will be 6.3 times 10 to the power of negative 3. So a better illustration, move 3 steps to the right. That's why your index is negative 3. All right, let's do a practice here. 380. Again, I'm going to add the 0.0. So the goal is to move the decimal to 1 step, 2 step. Now I have 3.8 in between 1 to 10. So I've moved 2 steps to the left. Therefore, my index is positive 2. 3.8 times 10 to the power of 2. Another practice, 0.004. The initial decimal is here. So I move 1 step, 2 step, 3 step until I have 4.0, which is in between 1 to 10. 3 step to the right. That's why my index is negative 3. All right, there will be time when you'll be asked to convert a standard form back to original number. So in the previous example, when you move to the left, the index is positive. So to convert it back, if your index here is positive, you have to move back to the right, the opposite. So initial value is 2.4 times 10 to the power of 6, which means this decimal have to move 6 steps. 1 step, 2 step, 3 step, 4 step, 5 step, 6 step. So to show you a better illustration, I've already created this. So you can see from here, move it here, move it here. And every time I move my decimal, the 0 is added, and eventually it'll just give me the final value. And for a very small number, it's the same thing. Previously, you moved to the right, now you just move it to the left. Again, I prepared an illustration, just move it here. So you got 0.36, then you move it again, 0.036, 0.0036, blah, blah, blah. And that's about it. You move 4 steps, that's when you get 0.00036. So it will also be important to know how to key in standard form into your calculator. So pull up your calculator. You will either see the E button here that represent times 10 to the power of something. So 3.2 E6 means 3.2 times 10 to the power of positive 6. If there's a negative, means negative. Or if you are using the same calculator as I do, you're going to have something like in this button, let's do 3 times 10. You will see this button, 3 times 10, and you can key in whatever indices you want. So look up into your calculator and see how you key in standard form into it. Alright, the next part of the lecture, we're going to look into how to multiply numbers that are in standard form. So to multiply the number, it is very easy. First, you do have to separate the number and also the powers. So once you have done that, you can just multiply the number, and then if you remember what we learned in the law of indices, you can do 10 to the power 4. Because it's multiplication, you just add up the index. So you can see add the power, multiply the number. So the final answer will be 6 times 10 to the power 7. So a more beautiful version would be like that. So the situation is the same when you are doing division in standard form. So the only difference is that instead of adding the power, you're subtracting the power. So to do that, you can just put both numbers into fractions and then let the numbers divide each other and the power divide each other. 10 to the power of 3, we just subtract the power, which is why you see 10 to the power of 3 here. And that's how you multiply and divide numbers. So here's a comparison between how you do it. They're pretty similar except this part of the solution. Alright, the next part of the lecture here involves adding numbers in standard form. Unlike in multiplication and division, it is not so straightforward because before you add two numbers, you do have to ensure that their powers of 10 are the same. So in this example here, to add these two numbers together, I'm going to make the first part of the standard form the same, but I'm going to change this part into, instead of 10 to the power of 5, I will change it to 10 to the power of 4. I will separate the two. So these two, they are essentially equivalent to 10 to the power of 5, but I'm separating it, which I'll show you why. So let's cancel this and then let 3.1 be here. And I will do a little bit of cleaning here, plus 3.1 times 10 will be 31 times 10 to the power of 4. So with this operation, you can see that now both numbers, they have the same power because I have split up this step beforehand. Once their powers are the same, I can now add them up very easily like that. 1 times 10 to the power of 4. And then when I add them up, I will be getting 36.2 times 10 to the power of 4. Again, because I want to represent standard form properly, I can always change it back to this format. 3.62 times 10 to the power of 5. So a beautiful version, I will change this into 31 times 10 to the power of 4, and they are equivalent to each other. All right. Once I have the same power, I will do the operations. So when it comes to subtraction, it is the same. You do have to make sure that their powers is the same. So in this case here, I choose to convert this. I move the decimal place 2 spot to the right to make it 10 to the power of 4 so that both are equals. Once I do that, I minus both numbers here, okay? And then let the standard form stay the same. Do the operation, and then convert that back into a proper standard form. All right, now let's try to solve some question. Write in standard form 5,400. So again, add 0.0 in front, and then you move 1, 2, 3 to the left. That's 4, you get 5.4 times 10 to the power of 3. So if you want to see proper way of doing it, that's how I have included the solution. As ordinary numbers, 6.7 times 10 to the power of negative 3. So you will move this decimal place 3 times. 1, 2, 3. So it will be 0.0067. So that is the final answer. Right, solve medium question. Multiplication of standard form. Again, you multiply the number differently. Here, and then let the indices add up because it's multiplication. And once you do that, you'll get 10 times 10 to the power of 10. Make it a proper standard form, 1 times 10 to the power of 11. All right, division is the same again. Just put them into fractions and then let the number divide each other, power divide each other. That will be 8 minus 2, 6, and then 0.4. Convert that into a proper standard form. That's the final answer. Well, hard question. So in this case, we have addition and subtraction. Again, the goal is first to make the power the same. So in this case here, you can actually change the power to any one that you like. For me, in this question, I decide to change this into negative 3 and this into negative 3 as well. So to convert this into 10 to the power of negative 3, I do have to make this a little bit smaller. Whereas for this, it's the opposite. I'll make it a little bit bigger. So once you have done that, you can just deal with the numbers separately. 6.2 plus 0.89 minus 25, multiply by the same standard form. And once you've done that, convert it back into a proper standard form. And with that, that's the end of this chapter. Thank you so much for watching. Let me know if you have any question, and I will see you next time. Goodbye.